Number 8 on your study guide, Yumiko has a rectangular shaped patio that's 10 feet by 14 feet. So her current patio. I'm going to draw a rectangle representing her patio. There it is. It is 10 feet by 14 feet. Okay. She wants to double the area of the patio by increasing the length and width by the same amount. Does it tell you how much she's increasing it by?
Double it.
She's doubling the area, but it doesn't tell us how much she's increasing the length and width by.
No.
No. So if you imagine a new patio for Yumiko, and let's just say it's like this. So there's my 10 by 14. We're going to add some amount to both the length and width. So we're going to be adding some amount x here. We're going to be adding some amount x here. Which makes the new length, so again 10 feet, let me just move the 10 feet inside. So 10 feet is this little bit. 10 feet's that little bit there, 14 feet's that little bit there, right? This right here is the new width. Which will be 10 feet plus x feet, right? And this right here would be the new length, which would be the old length, 14 feet plus x feet. And we want that deck to have double the area of the original deck. So first thing I might ask myself is, what is the original area? All right? So if I have a 10 by 14 deck here, how do you find area of a rectangle? Length times width. So 10 times 14 is 140 square feet, right? So the area of the deck that's the black rectangle, this right here, is 140 square feet. If we're expanding the length by x feet and the width by x feet, creating this new blue rectangle, the area, the new area should be what? 280 square feet. That's for the whole big blue rectangle.
Wait, how'd you get that?
I doubled the area.
Oh, okay.
So again, she said she wants to double the area. We knew what the area used to be. We're going to double it. So it's times 2. So looking at the picture that I've created here, my original dimension is 14 by 10. I've gone x more feet that way and x more feet this way. My new area should be twice as much as it used to be. 140 times 2 is 280. And I know that length times width equals area. So the blue rectangle dimensions are 14 plus x length, 10 plus x width, area 280. So I know 14 plus x in parentheses times 10 plus x in parentheses equals 280. So that's how I set up an equation containing the variable x only. If I can figure out what x equals that makes that product equal to 280, I'm good to go. Okay, algebraically, here's how I do it. I'm going to multiply 14 plus x times 10 plus x by doing either FOIL or the distributive property. I usually do FOIL. Let me do the distributive property. They do the same thing. 14, the first number gets multiplied by both of these numbers. 14 times 10 is 140. 14 times positive x is positive 14x. Then I multiply positive x times both of these numbers. Positive x times 10 is positive 10x. Positive x times x is positive x squared. All that equals 280. Okay. Multiplying it out, notice it creates a quadratic structure. X to the second power is there. So now we've got a quadratic equation. The best form for a quadratic equation is x squared, something x, something equals 0, right? So the things messing that up is the order here is no good. I got a couple x objects. I've got a number over on that side that isn't 0, so I want to make modifications to the equation. So I'm going to chop the 280, put it over here. So now everything over here equals 0. And over here I want x squared, x constant equals 0. So this is the only object making x squared, so that's the first part of my equation. Both of these things have x. 14x and 10x makes 24x. And these two are both constants, so I get minus 140 equals 0. Okay, now one clue that the problem gives me to let me know that factoring probably won't work. It says to the nearest hundredth of a foot. Okay, that implies that it's not going to be some nice friendly answer like 6.
Dang it.
All right, so it's not going to be a friendly answer probably when they say round to the nearest hundredth of a foot. So I'm going to assume completing the square might be necessary to solve this. I don't think factoring will work.
6.
So if I'm going to complete the square, recalling how we do that from the last chapter, I'm going to move my 140, the constant, to the other side, because there is no number in front of x squared. We don't have to divide by a. So I'm going to have x squared plus 12x, leave a gap, equals 140. I'm sorry, 24x,
I was
not
going to
12x.
say.
I'm dividing by 2 in my head before I start doing it. So x squared plus 24x equals 140. Notice 140 is positive. It moved from left negative, came right positive. Half of 24 is 12, so I'm going to add 12 squared to both sides. 12 squared on this side I'm going to write 144.
Wait, where'd you get the 12?
Half of 24 is 12. So again, completing the square, that's how we do it. There's always that magic number that works. That magic number is always half of the x times itself. So half of 24 is 12. 12 squared is what the magic number is. So x squared plus 24x plus 12 squared equals 140 plus 144. So again, I added 144 here. I added 144 there. I just have different forms of 144 because on the left-hand side, I'm now going to factor. And factoring is always this square root, which is x, this square root, which is 12, and this sign, which is plus. So again, if you leave it in square form, it's much easier to factor. It's worth doing. The right-hand side, we just add them up. 140 plus 144 is 284. So x plus 12 squared equals 284.
Square root.
Now we're going to square root both sides. Remember when we square root both sides, I square root the left, I square root the right. I'm going to put a plus or minus on that one. So x plus 12 squared, square root becomes x plus 12. The square root of 284 says to the nearest hundredth of a foot, so I'm going to get a calculator to evaluate that.
I already did it.
Did you?
Yep.
What'd you get for square root of 284?
16.85229955.
I believe you. 16.85 you said?
Yep.
And the square root.
284 square root. Hey, look at that. 16.852299. All right, so let's go 16.85. It is plus or minus, right? Good job. And then finally, to get the answers, plus or minus means two answers, right? We're going to move the 12 over. I'm going to get x equals negative 12 plus or minus 16.85. Which translates to x either equals negative 12 plus 16.85, which is 4.85 feet, or x equals negative 12 minus 16.85, which is negative 28.85 feet. Do both those answers seem to make sense? Do they seem logical? Or does anything seem illogical?
What's 52?
Does a positive 4.85 feet seem logical?
Seems perfect.
Does a negative 28.85 feet seem logical?
Yep.
The amount that we're going to increase the deck by is negative 28.85 feet. Does that seem logical? No, it doesn't, right? We're talking about dimensions on a deck. Dimensions should be positive, right? We're supposed to be adding a certain amount. So this answer, because it's negative, is irrelevant. It doesn't matter. We throw that one out. Sometimes that happens when you do a word problem. You get answers that, in the context of the word problem, don't make sense. Okay, with quadratics, you usually get two answers. Sometimes you get two positive answers. Quite often you get one positive, one negative. If we're trying to build a deck, we're not going to get a negative answer. So it says, what are the new dimensions of the patio? The new dimensions are 14 plus x for the length. And the width is 10 plus x. We just found out x to be 4.85 feet, right? So we take whatever x is and we add it to the dimensions. So the new deck should be 18.85 feet by 14.85 feet. What's the area of this deck supposed to be? 280. Watch what happens when I multiply those two numbers. 18.85 times 14.85 equals almost 280. We rounded, so we're not exactly 280, right? Yeah, that's what happens. You round, you don't get to be exact. But again, that's what happens. So that's how you do that problem. Draw a picture, apply whatever they're doing to the picture, and if you're expanding something or decreasing something, call that change x, and use whatever formula to do to create some sort of an equation to solve for x, and then answer the question. All right. Number 9. Write y equals 8x squared plus 16x minus 42 in vertex form. What's the maximum or minimum value of the graph of the function? State whether it is a maximum or a minimum. So, way we make vertex form. Again, vertex form, if you recall, looks like this. Y minus k equals a times x minus h, the quantity squared. That's what it looks like. So making vertex form is just transforming the equation into this structure. And the way we do that is, first off, the first thing you look at when you're making vertex form is everything that's not x has to go on one side, everything that is x goes on the other side. So the first step of vertex form is just rearrange things so that everything not x is on one side, everything x is on the other. I like x squared to be positive, so currently x squared is positive where it's at, so I'm going to leave it right where it's at. I like y positive. Let's say y positive is more important. X squared positive doesn't matter as much. Make sure y is positive. So if it says y equals, you're good to go. So y plus 42 equals 8x squared plus 16x. So that's the first step. Just rearrange. Everything x on one side, everything not x on the other. Step 2, very, very important. We're going to be completing the square. We must have 1x squared to do it. If we have 1x squared, we're ready to go. If we don't, we need to make it happen. So we're not going to divide by 8. We're going to factor 8 out. All right? Divide would mean divide everything by 8. We just want to deal with this side all by itself. So I'm going to write down 8 parentheses. I don't care if the numbers divide by 8. I just care that I get this number out of there. So whatever this number is, stick it right there. No matter what happens, anything else, I don't care what happens to anything else, I need that number to be out of the picture. So I put that down. I'm going to divide both these objects by that number. Whatever happens, happens. 8x squared divided by 8 is 1x squared. 16x divided by 8 is positive 2x. And then I'm going to leave a little space. Even if this said 3x, and this says 3/8x, I don't care. This needs to say x squared. If this doesn't say x squared, I can't do the problem. So whatever this number is here, this right here, that guy, you need to pull that out. Divide everything by it, let whatever happens happen. When you do that step, there's no effect on this side. Y plus 42 stays the same. Just bring it down though, so you're not looking at two different levels. Part of the problem's up here, part's down there. So just, you made a change down here, bring this stuff down. So now this is where the problem lives, down here. Everything up here doesn't matter anymore because we're done with it. Now it's where we complete the square. Completing the square is a matter of taking half of this guy and squaring it. What's half of 2? 1. And what's 1 times 1? 1. So 1, half of 2, and then squared 1. So I'm going to be adding 1 here. Now, I added 1 inside of parentheses that's currently being multiplied by the number 8. So on the right-hand side of the equation, even though I did plus 1, I wrote the number plus 1 right there. I, in essence, added 8 to that side because 8's outside of here, right? So if I distribute 8x squared plus 16x plus 8, right? By putting a plus 1 there, it made this side over here 8 bigger. So I have to make this side over here 8 bigger. Again, these numbers will not always match. But this times this will match what that is. That's the only tricky part in this problem. You have to complete the square, you have to put plus something here, but that something might be multiplied by something else. That's what you have to modify over here. So I've got y plus 50 now on this side, and I've got 8 parentheses squared, and now I'm just going to square root it just like I did the last problem. Square root of x squared is x, square root of 1 is 1, the sign of the middle term is plus. And there's my vertex form. Now what the vertex form tells me lots of stuff. First thing it tells me is that A is equal to 8, because that's what this number is.
It's fine.
What?
How'd you get the plus 8 not minus 8?
So you're thinking, going back to algebra, when we move something across, we change the sign, right? If I have that, right? We go chop plus 3, right? What made that happen? Oops. If I chop plus 3, what makes that happen is I do plus 3 on one side, plus 3 on the other side. Adding the same amount to both sides
Okay.
causes that to chop and causes that to be opposite there. Here I did plus 8, I did plus 8, okay? You aren't the first person to think that, so.
So how'd you get the x squared to just become just x?
You do it square.
I made a perfect square trinomial. Anytime I complete the square, anytime I do this deal here, half of this squared, it always factors to parentheses squared, square root sign. I did it over here too, look, Larson. X squared, 24x plus 12 squared, right?
Mm-hmm.
Square root, sign, squared. Every time you do this process, complete the square, that's the next step, factor. It always factors to square root, and sign, squared, every time. Same thing here. So, square root of x, square root of 1, 1, sine 2. All right? So, A is equal to 8 because A is the number in front of the parentheses. And if A is 8, the parabola created is going to turn upward, right? And an upward turning parabola has a minimum or a maximum?
Minimum.
Minimum. It's got a lowest point, right? So it says state whether it's minimum or maximum. It's a minimum. And then we just need the number. Minimum of what? So the vertex here, okay, the vertex formula, notice it says minus h and minus k. H is with x, k is with y, right? This is the x number, this is y number, but they're the wrong signs. In the formula, they're the wrong signs, so I'm going to change the signs. So the h value is -1, the k value is -50. That's my vertex. The vertex is the point at the bottom of this parabola, the lowest point. When it asks for a minimum value, it's asked for the y value. So minimum of -50 is what we get out of that.
Well, when you get -1, do you just change this? Did you just change the sign?
Yeah, exactly. Whatever. So again, what we're looking at here, once we get the vertex form done, once you create this structure here, right? Y plus or minus something equals number times x plus or minus something squared. Once you get this look, whatever this number is and whatever this number is, because this says minus k and this says minus h, it means the signs are wrong. So whatever sign's in the problem, the opposite sign is what you should be
So if
using.
they were negative, then it would be positive.
If that said -1, this would be +1.
Okay.
Whatever this is, change it. Whatever this is, change it. X goes first, Y goes second.
Okay.
But again, because the formula says minus, that means the signs are wrong. Once you get the formula, you just change the signs. Any other confusion on that? I'm going to stop recording now. The other 7 are already recorded.